Okay, thank you very much. Some of you might remember Josh Baer at Spotify last year. His talk about Spotify's platforms was one of the most interesting, in my view, of last year's edition. And thanks to Josh Baer, and after some intense search, we managed to eventually meet Irene Gonzalvez, who is coming from Stockholm to discuss a topic that is not very well covered here at the conference, but I think is a very interesting one, big data and big quality. So Irene, thank you very much.
One of my good now. Food is one of my passions. I love going to different restaurants and trying new food. I really like how the different ingredients get mixed up in my mouth, and then I get an explosion of flavors that I didn't expect beforehand. You might or might not share this passion with me, but food is essential to all the human beings. And for that reason, I'm sure you will never eat rotten or spoiled food. Otherwise, best thing it can happen to you is to get sick. The same thing happens with data. Doesn't matter how much data we collect on a daily basis. Doesn't matter how complex machine learning algorithms we use to get insights. If the data we use is not of right quality, your company is definitely doomed for failure. By transforming raw data into value, we can react fast to problems. We can build new products. We can even change the way we work. If your company is not able to do that, you will definitely be left behind. At Spotify, we always use A/B testing when we are planning to release a new feature. And that's what we did a couple of years back. And what is funny is when we analyze the result, everyone seemed to like the feature. 100% of the people that we tried out seemed to like it. And while that is obviously really great news, it's a little bit scary and strange. So we decided to go deeper into the analysis and realize that exactly to the same people that we applied its new feature, we removed the advertisement. So obviously, bad data caused that the results that we got were not really accurate in any way. And just for your information, that feature was never launched. Because when we redid the A/B testing, we realized that that's not exactly what our customers were looking for. My name is Irene Gonzalvez, and I work as a product manager in the data infrastructure department at Spotify. Today, the aim of my talk is to make everyone aware of the importance of data quality and that you feel passionate about this topic as I am. I'm going to give you some takeaways of things that you can already start thinking today, and hopefully start working on that already on Monday when you get back to the office. I'm going to talk about how we became aware of the importance of data quality at Spotify. I'm going to continue talking about the different products that we have built and we are currently using, and also about our future strategy in the data quality domain. And I will reserve the last 5 minutes for Q&A. Just to back up and be sure that everyone is on the same page, Spotify is a music streaming service. We are present in more than 60 countries at the moment, and we launched our service in 2006. We have free and premium subscribers. We have over 140 million active users monthly, a catalog with more than 3 million songs, and over I see I'm having problems with the remote as well, and over 1 billion plays per day. Billion with B. So I think with these numbers, it's fair to say that Spotify is a big data company. We use data to connect creators with fans, to provide music recommendation, for example, Discover Weekly or the recently launched Time Capsule, to provide target advertisement, and obviously to pay artists and right holders. And I would say that data is really in our veins, that we even have a motto on that: data first. And I personally feel really identified about that, and when I talk to my colleagues about that, they share the same idea. But when I say data first, do I really mean data of good quality first? And I just shorten it because it's a little bit too long? I see, even though I don't see too much from here, I see some people in the audience actually shaking their heads, and that would exactly be my answer. Unfortunately not. However, it's fair to say that it really depends on how business critical your data is. But even in those cases, data, like the quality that we have, the quality checks, is not optimal in any way. Data quality problems cost the US business $600 billion a year. Obviously, there is a problem. I don't think we need to discuss or agree on that. Everyone agrees on it. And how did we become aware of data quality or the importance of data quality at Spotify? So summer of 2015, everyone here might think about beach, swimming pool, vacation. But for us at the Spotify, we even have a name for that, the summer of incidents. So someone manually checking the storage, that data, business critical data that should have been arrived like 20 hours ago was not even there. And what it was a bit more scary is that when we tried to identify the root cause, we realized that we were reaching the limits for Kafka and Hadoop. Fortunately, we solved the problem, but that could have been the end of Spotify, because losing business critical events means that we cannot pay artists and right holders. And we overcome the problem. And looking at the positive side, that meant a huge change in mentality, from being reactive to become super proactive. We try to copy the same high quality standards that we have in our backend service in the data quality or in the data domain. We are talking about, or I'm talking a lot about data quality. But what is really data quality? I would say it really depends on your background, your context, your activity. And I would say that most of you, even all of you, are totally right. But if I can just summarize what data quality means in one sentence, I would say that data is of good quality if it serves its purpose in a given context. And if we want to go deeper, people talk a lot about different dimensions. There are 12 dimensions. Some other people talk about the 4 V's. But what I can say and what I have seen is that there is no agreement or consensus around that. So what we have done at Spotify is to take the 4 dimensions that we think are the most critical ones for our business and just try to tackle them one by one. So timely. It means that data is there for consumption in a specified SLO. Correctness. Data is correct with respect to some specifications. And if we try to link it to the pipeline world, some input data produces the expected output. Completeness, all the data that is needed for the current and future business use cases is available. And finally, consistency. All data across different systems is in sync or means the same thing. So this is Datamon. Datamon is our data monitoring tool that will alert pipeline owners when data is not arriving at specified SLO. Datamon is the first system that we created after the summer of incidents. Datamon is integrated with PagerDuty, so that means that we will alert engineering teams when their data is late. And additionally, it's also integrated with Jira, meaning that if your data is late, you will immediately get an incident created. So if we got a little bit into details, here, due to confidential issues, I had to remove some of the names, but this is basically how it looked like. Datamon will monitor endpoints, components, and systems. This is terminology that we use at Spotify, and I will mainly focus on endpoints. But just to give you like a brief definition of what those means, endpoint is basically a storage where data can be or is going to be produced and where data can be consumed from. Component is any metadata. It can be a backend service. It can be a library, basically anything that Spotify can own. And system is just a grouping of the previous ones. So if we just look into the middle column, here we will see all the endpoints that me as a user at Spotify will own. And that is basically based on the LDAP group. On the left side is endpoints that even though I don't own, I want to mark them as favorite. So for example, let's say that my data is late. And my data is late maybe due to an upstream dependency. I want to see that quickly. Like if I'm woken up in the middle of the night, I'm going to come here and just check, OK, my data is late, but I see that one of my upstream dependencies is late as well. I might not be able to do anything. And on the right side is just useful information regarding all the data incidents for the whole Spotify, who to contact, and additional documentation. So if we go into detail, here it is. One of my favorite things about Datamon is you can create our customized dashboards. So here you can see all the different endpoints that you might own, or you might not, but you are still interested. So far, everything looks green. Obviously, green is everything is successful. But then we have some gray and some blue. Gray means that the data hasn't yet arrived, but that's not a problem, because the SLO is not broken. Otherwise, it would be red. And blue means that even though the data is still not there, it has been scheduled. The job has been scheduled for running. So it's going to be coming anytime soon. And obviously, if you require more information, there is a legend at the end. So if we click on one of these endpoints, we will again get the timeline for the last 7 days, knowing like if our data was late or not, if we met the SLOs or not. But we will also get some extra information. For example, who owns the endpoint, to which component or system it belongs, if the job runs on an hourly basis, or daily, or quarterly, or monthly. Additionally, some rules. And that is key for Datamon. We need to provide the rules. So in this case, the SLO is going to be 72 hours. And we don't expect any holes or any missing partitions. Data should always arrive hour by hour. And I think it's important as well to mention, as I already said, like Datamon is integrated with PagerDuty. And we provide 2 different keys for alerting. So let's say that your data should always be there because the SLO marked that at 72 hours. So obviously, you will get most likely a call saying that your data is late. Look into that, what happens. But you as owner of your data, you know your data the best. So you can say, for this particular endpoint, I know that data will arrive normally after 40 hours. So you can have a PagerDuty key for alerting. You will get, maybe it's not going to be a call in the middle of the night, but you might get an email saying, well, your data normally arrives at this time. It's not. Take a look. It might be a problem. It might not be, but it's just some kind of warning. And that is what Datamon is around, or is about. Next system I want to talk about is data counters. So data counters is a system that collects metrics coming from different data processing frameworks. We use it for Hadoop MapReduce. We use it for Dataproc or Geo Dataflow. I think Josh mentioned that last year, but we have already moved all our infrastructure from Hadoop to Google Cloud, and this was key in order to succeed. So we were able to put counters, metrics, in the old jobs running in a Hadoop cluster and in the new jobs running on GCP, and just compare. That's a good way to check if what we have migrated looks exactly the same as before, if it should look exactly the same. So data counters, for example, we can count the number of playlists that we have at Spotify. We can count number of songs that are played hourly. And with that, we have also been able to detect fraudulent users. So getting back to the counter around a number of playlists played on an hourly basis, we suddenly saw a huge increment on that. And when analyzed it, we realized that someone was using the service in a fraudulent way. Additionally, another example that I can put for number of playlists because we are getting more and more users, and the existing users are providing or are creating more playlists, this number is going to be increased. Of course, people drop and so on, and there could be some kind of decrease. But if suddenly the number of playlists that we are measuring drops by 50%, obviously there is something to look at. So this is just a time series. You can see the last 7 days, how it looks like. And if you want to get more information, you can just export it, all the data automatically to Kibana to get those details. And when we release counters, data counters, we really saw that people started to put some rules on top of that. As I just mentioned, like if my number of playlists decreases by 50% or increases by 30%, it looks a little bit suspicious. So based on that, we created MetriLab. And we created this in the beginning with a really high ambition. So we thought, what is the best way that we can think about to detect anomaly detection in our data? Machine learning. So we started to talk with some machine learning experts at Spotify, with some researchers, and with people owning big business-critical data. And what we realized is that we had some of these machine learning experts implementing ad hoc algorithms for people owning business-critical data. And the problem is that they were woken up in the middle of the night, and they didn't know how to solve the problem and what to solve. So we immediately thought, like, this strategy is a bit too ambitious. We need to back up a little bit and rethink. And instead of that, what we thought is, it's going to be key for us, because we are working with alerting and monitoring, that people really understand what they are getting back, that we can explain the output. So if you are getting alerted in the middle of the night, you know exactly what you need to look at and how to solve it. So all our algorithms or rules needed to be explainable for our data engineering teams. So we came up with 2 very simple rules, but those rules can be applicable to all the use cases at Spotify. Obviously, we will not cover everything, but it would be kind of to increase awareness of the importance of data quality. So for example, here, we had a function that will count the number of invalid Avro records. Because it's invalid, it's going to be close to 0. And I would say that looks more or less that, but we have some peaks here and there. So we have a rule like minimum and maximum threshold that you can define to detect the different anomalies. So here we set it up to 20, sorry. Here we set it up to 20. And then we see the red dots, and that means that there is an anomaly. We have just a time span of 1 week. But we can increase it, and that's the second image, the one at the bottom. And then when we increase it, we realize that we really have a lot of anomalies. And that could make sense, but maybe that doesn't really make sense. So we can still tweak it and increase the value. And increase the value a little bit to 8 in this case. So we are getting less anomalies. If that is good or not, I don't really know. It really depends on you and your data. But at least we provide the functionality or the possibility for you to tweak the different rules and then make sure that you get alerted. Not too much, but not too little. Just the right balance. And if you want to get more details on your data, you just need to zoom in. And another rule that we have implemented is compare our current partition with previous partitions. So in this case, instead of talking about absolute thresholds, we are talking about percentage and comparison with previous partitions. So if I put out an example, the habits of listening music today at this time are not the same as during a weekend. So that could be a way to predict that. And sorry, not predict, but more like to compare. And we are comparing the right partitions. So just to recap a little bit, Datamon focuses on the timely dimension, while data counters and MetriLab focuses on the correctness of data. So for us, or for Spotify, next thing we are planning to target is completeness and consistency. But data quality problems don't happen in isolation. So it's really important to create a culture and environment where people can sit down and talk and discuss about problems and different solutions. So we can create a lot of products, and maybe all of them are great, but if people don't use it, if our engineers at Spotify don't use it, it doesn't have any value. So what we have done is a program that will enforce best practices when creating pipelines. We call it TC4D, Test Certified for Data. We have different levels depending on the quality that you apply. So level 1 is mainly around setting up your pipeline, adding some monitoring and alerting, and some really basic documentation. Level 2 is more around, a little bit more around quality, for example, adding some data counters into your pipeline, and also some unit testing. And level 3, which would be the most advanced one, would be that you always produce the data on time, and what you are producing is of good quality, or it has high quality standards. And if that is not really the case, then you shouldn't publish that data. Your job should stop. At Spotify, we have we have thousands of pipelines, and what I can say is we just have 37 so far certified. None of them are level 0, and just 5 are level 2. So I would say that still we have a long way to go. So what is next for us? So if we talk about the products that I just described, for us is machine learning for all. So we don't believe that every single engineering team is going to have a machine learning expert in it, but what we do believe is that every single team at Spotify can benefit from the potential of machine learning. So what we want is to build an algorithm library that everyone can benefit from. We have started clustering the different functions that we have. Obviously, we cannot apply the same anomaly detection algorithm to one constant function, or to one exponential function, or to one time series. They will have to look the same. And even though we will try to provide a really complete library, we will try to provide infrastructure, or we will provide infrastructure for people to plug and play their own algorithms. And finally, because data quality is not a first-class citizen in our data strategy or in our data world, what we want is to simplify things as much as possible for our engineers at Spotify. And what we want to do is to provide parameter recommendations to the algorithms that we will provide them, or that we will produce for them. And that means that I have already mentioned that you know your data the best. And if you are talking about, or if you are working with business-critical data, you know possibly exactly which thresholds or which parameters or how to tweak the different algorithms. But if you are not, it's always great to say, getting back to the example before, use 60. Don't use 20 or 80. And why is that? Because we have some machine learning that is plugged into our algorithms that will tell you the parameters that we recommend you to use. And if we try to zoom out a little bit, for Spotify, I've been talking a lot about data quality, good data quality. We need good quality. But, sorry, next slide. Cool, yeah. So I have been talking a lot about good quality. But when we think about good quality, good is a really vague word that we are using. So what we are trying to do at Spotify is to define the metrics that for us define, or define what data quality, or what good data quality means. And also, we will identify which data sets are critical or central to Spotify and make them of good quality. So I know you have been receiving so much information today, really great talks, but I want to give you like 3 main takeaways that you go home and go to the office and think about that. Because the data quality space is really broad, it's really important that you conduct as deep as possible and as wide as possible analysis of your data. Try to understand your company's pain points. You really need to think big. However, it's really hard to start tackling everything at the same time. So what I recommend is that you prioritize your findings and start small. Start one by one, and don't wait. Start now. And last but not least, Data quality is not an add-on. You shouldn't think about data quality as an afterthought, but more as something that you build when you are creating new products, new algorithms, when you are planning to analyze your data. Don't think about, well, when I have some spare cycles, I'm going to apply some data quality checks, or I'm going to have some counters. We all know that that never happens. And just remember that insights can only be as good as your data. So I was planning to ask you that question, but obviously now you already saw the solution. So data will increase by 10x by 2025 compared to last year. And that is a huge increment. We will produce, and when I say we, I mean the world, will produce 163 zettabytes of data. And zettabytes is 1 trillion gigabytes. And out of this data, 20% is going to be critical to our daily lives. 10% is going to be even hypercritical. So please remember that it's not the same thing to lose an Excel sheet because your computer broke than cause physical damage because the data that you are using in a self-driving car is not accurate. So this is our journey. This is a Spotify journey in the data quality space. I talk about how we became aware of quality at Spotify. I presented some of the products that we are currently using, and I also described the strategy that we are following. So thank you very much, and I have like a couple of minutes late, so I'm open for questions. And if you don't have any questions now, I'm going to be here today and tomorrow. So grab me anytime, and we can talk further. Thank you so much.